So we're doing 4.3 and 4.4, which is transforming parabolas. That basically means that if you have a graph of a parabola, basically if you're given the equation, you should be able to tell the graph. And really, if you have the graph, you should be able to write an equation. It's only going to work for one certain form of quadratic equations. We're going to go over that at the end. So really quick, transforming is a fancy math word for moving or changing a graph. So if you had something like this and you have a parabola here, and then you had a parabola here, it transformed by moving to the right. Or you can have a parabola that looks like this, and then you shift it so it becomes like this. Okay, we compressed it or stretched it, however you want to say it. That's what it means by transforming. So let's go, we're gonna go through all this stuff. Let's do this first. This is our base graph, y equals x squared. This is the simplest parabola we can graph. I'm gonna do a table of values really fast. Okay. I like to include negatives so I get to see like both sides of the equation, what's going on. If I sub these numbers in the equation, my y values would be 4, 1, 0, 1, 4. Right? I sub this number into the value for x. That's not new information. I'm going to graph this. So negative 2, 4 is here. Negative 1, 1, 0, 0, 1, 1, and 2, 4. Okay? That's my base parabola. Now, writing the table of values and then copying each point took a really long time. So we're going to come up with a way that we could do it better. I want to show you this thing called the step method. Okay? There's actually a pattern with when we graph parabolas that's always true and can help us. So what I want you to see is we're always going to start at the vertex. Okay? As we go through the lesson, it's going to be easy to see what the vertex is. For this one, I'm going to cheat. I know the vertex is at 0, 0. Okay? Hold on a sec. Let's move this over. Okay, so I'm going to start at that 0, 0 like we said right there. Let's make it red so it's easier to see. Okay, then what I'm going to do for my step method, it follows this pattern. Okay, the first number is over, so you go like to the right, and the second number is up, and you go up. So from that first dot, I'm going to follow the pattern. I go over 1 and up 1. Then the next one, I'm going to go over 1, up 3. And the next one, I'm going to go over 1, up 5. And if I did the next one, it would be over 1, up 7, and on and on. Okay? I'm sure you can see what the pattern is. It's really easy to remember. This strategy means that we can graph parabolas very, very quickly. The other half of the parabola you notice is missing. These are all mirror points. So what we can do is, I see that this is 1 away from the vertex. So 1 away from the vertex on this side, that will be the same value. And then over here, and over here. Each of these is like the same distance from the axis of symmetry that goes right down the middle. It's a terrible line, but okay. All right. So that's how we can quickly graph a parabola. You start at that vertex, over 1, up 1, over 1, up 3, over 1, up 5. So now we have to deal with questions like these ones where the vertex isn't at the origin. Okay. When we have a number at the end. Okay, so we have our x squared there, no issues with that. And then there's like basically this plus or minus at the end. What that does is it shifts the parabola either up or down. If it's plus, it's going up. If it's minus, it's going down. So what we're going to do, we always are going to start with the vertex. You assume it's going to start at 0, 0 because that's y equals x squared. And then you have to apply whatever the change is. So in this case, we would have started 0, 0, but it says plus 3. So I'm actually going to start my parabola right here at this point, 3 above it. Okay? In this one, it started at minus 5. So I'm going to start it down here, 5 below it. Okay? From that vertex, we're then going to use our step pattern, the thing we just talked about, to draw the rest of the points. So I'm going to write it again so we can see it. Okay? So for this first one, over 1, up 1, first point. Over 1, up 3. Then over 1, up 5 goes off the graph. I'm going to draw my mirror points. Bam, parabola done. Takes like 5 seconds. Let's do the second one, make it red. Okay, start our vertex. Over 1, up 1. Over 1, up 3. Over 1, up 5. Okay, over 1, up 7 goes off the graph. And again, we can draw our mirror points. I really should be connecting these. I'm just really bad at making it look good. Okay? That's it. That's all we have to do. So when there's a plus or a minus at the end, that's a vertical shift, either up or down. These ones look a little different. You'll notice that the plus or the minus is inside the bracket with the x, and then the whole thing is squared. Okay? When you have a situation like this, it's going to shift right or left. The way that this works is it's always backwards. Okay? The one we did before, up was positive, down was negative. That makes sense. That's logical in our heads. Here, if it's plus a number, it's actually going to go left. And here, it's minus a number. That one's going to go right. Okay? And again, we're starting with the vertex. So let's do it, and then I'll explain why it's backwards. So this first one, we're supposed to start at 0, 0, but it was plus 1, which means we move left. So I'm actually going to shift 1 over right there. Bam, that's our start. Then we do the rest of the step value. Over 1, up 1, over 1, up 3, over 1, up 5, same idea. I usually just do 5 points because that's enough for a parabola. Okay? For this one, instead of starting at 0, 0, I go 4 to the right on my vertex, over 1, up 1, over 1, up 3, mirror points. Done. Okay? I want to explain why this works really quick. If I were to sub in, let's say, -1 into the equation, okay? So let's sub in -1 and see what we get. It's going to give me y equals -1 plus 1 squared, 0. Okay? So what we notice is that when we put the opposite of the number, like the -1, instead of the +1, it becomes 0 and gives us the x-intercept there. So it's actually like if it was +1, if we put -1, it becomes the vertex over there. If we had actually put in 1, so like this point right here, it becomes 2. 2 squared is 4, which is way higher. Okay? Oh, my bad. That should have been up 3. That should be that point right there. I'm sorry. Yeah, I did it right on the other one. Okay? That's why it's backwards. If it helps you to remember that, or you have to check, you can always go back to doing your table of values. This will always work for every question. It's just really slow. All right, couple more. This one, this is the value in front of x, and it's basically multiplying. So what this means is that every value in the graph is going to be twice as high. So again, what you do is you're going to graph your normal vertex. We didn't shift up or down or left or right, so it's actually going to start at the same spot at the origin. Now, what we're going to do is I'm going to take my step counter like I normally did. But what we're going to do is all these numbers, we're not going to do the normal step increase. We're going to multiply it by that number. So it's supposed to be times 2. So it should really be up 2, up 6, up 10. So let's do it. We start from here. We go over 1, up 2. Over 1, up 6. Okay? And when we graph it, and let's put the points really quick, we can actually see these values are double what the normal parabola would have been. Normal parabola would have been here, 1 and 4. So 1 doubles to 2, 4 doubles to 8. Okay? So that's how we do it. We start from the vertex, and then we double our step value so we can see how much to increase by. This one's going to work the same way, except our step value, instead of going 1, 1, 1, 2, 3, 1, 5, we're going to multiply these middle numbers again, but instead we're going to multiply them by 1/2 or 0.5, whatever. So it's actually going to be over 1, up 0.5, over 1, up 1.5, over 1, up 2.5. This can get kind of weird with fractions, and it might be easier to leave these as fractions, but again, we're graphing. It depends on how accurate your scale is. So we start with the vertex, and we didn't shift up or down, left or right. Then I'm going to go over 1, up 1/2. And then from there, I'm going to go over 1, up 1.5. So if I have 1/2 and I add 1.5, that'll get me to 2. And then I go over 1, up 2.5. Okay, and I could keep going. That gives me my parabola, put my mirror points. Bam, that's actually enough for me. Okay, and we're good. Be very careful with the fractions. If you're getting weird numbers, it might actually be easier to do your table of values. Last part, negatives, okay? Basically what's happening with a negative is everything's getting flipped. If you think about it, it makes sense. When you had a graph like this, right, linear equations, that was like y equals x, okay? If you flipped it, it would look like this, and this would be y equals -x. So we're going to do the same idea, and what's going to happen is for your step value, we are going to multiply these by this coefficient, which is -1. So instead of going over 1, up 1, we go over 1, down 1, over 1, down 3, over 1, down 5. So let's start at the vertex. Same, we didn't shift up or down, left or right. We're going to go over 1, down 1, over 1, down 3. Okay, and we got our mirror points. What I find makes this really easy to remember is this is negative. Obviously, right? This is a negative coefficient for x squared. This is a frowny face. Negatives are sad. That's how you can really easily remember. Normal parabolas are smiley faces because they're positive. This is a negative equation, so it is a negative graph. It is a negative face, okay? You can laugh, but if it helps you remember, I don't care. Now, most of the questions you're going to deal with are going to do more than one transformation at a time. So let's do this last challenge one, and we'll break down the pieces. Again, the first thing we do is the vertex. Even though this shift is the first thing in the equation, we're going to do it last, okay? You're going to do the horizontal and vertical shift. It doesn't matter which order you do those, okay? I like to do the vertical first, but it doesn't matter. No, I like to do the horizontal first to remember to do it backwards. So it's negative, so I need to go to the right by 2. Then I need to go up by 5. So it's actually going to be there. That's my vertex, okay? Then I'm going to do my step value. I'm going to multiply each of these by -3. So they're going to become -3, -9, -15. Ooh. Sorry about that. Okay. So from that point, I go over 1, down 3. Then I go over 1, down 9. 1, 2. I think that's 9. Okay, draw my mirror points. Cool, and I got my graph. Okay. What you're going to notice with this is that this only works with this type of equation. This is a magical form called vertex form. Okay. You've been dealing mostly with standard form, which is like this. Here, I'll just draw a question. Okay. This sucks and doesn't help you graph at all. This is awesome, and it's really easy to graph. The positive vertex form, you can instantly tell the vertex. It takes you like 1.5 seconds. If I have a question like this, I can tell right away. That's the shift, that's the shift. So my vertex is going to be, for the x value, 1 to the left and down 5. Bam, vertex done. Okay? Axis of symmetry. I know it goes through that in the middle, right? There. So my axis of symmetry is going to be x equals -1. That's done too. I know it's going to be a smiley face because that's positive, like that. So I know that it's going to have a minimum value. Okay, what's the other things we asked about? Oh, it opens upwards. It's really easy to tell. And the domain and range. Domain is always XCR. Oh, that was the worst X ever. Okay, domain is always XCR for parabolas. The range is going to be, what do we got? It was -5 is our low point. So we have to say y is greater than or equal to -5 because it goes up from there. Cool. So what I want you to understand is that when you have a parabola that's written like this, an equation, it really helps just to sketch it. And I mean sketch it in like a second. So I'm like -1, okay, so that's like down here-ish. That's the parabola. It opens up. It'll be skinny because it's stretched. Cool. Now that you have this super instant sketch, you can do all types of questions with it. This picture should only take you like 3 seconds to draw. Trying to do it in your head, you're going to make a mistake. So sketch it, even if they don't give you like a nice graph where you have to actually graph it, sketch it just so you can see, so that you can get all the rest of the questions about stuff like this right. Last thing, if you are given an equation in stupid form, I mean standard form, and you want to graph it, I suggest to turn it into standard vertex form, complete the square. That's why we learned how to do that. Oh my gosh, so many letters. Square. Okay. When you complete the square, you will actually turn it into vertex form. Go look at your old notes from last unit and see it. They're all in vertex form, which means you can graph them very, very quickly. Okay. So that's why we learned completing the square, because as much as it is annoying to do, it helps us to graph so much. Okay. So that's the basics. And this is one of the most important things for this unit, is how to graph this stuff. All the other stuff for this unit builds on this core concept. So make sure that you understand how to shift stuff, whether it's moving stuff to the left, moving stuff up, stretching it, flipping it upside down, whatever. Those are the 4 big shifts. And that's it.